Hello and welcome to the Polymath World channel. I'm delighted to be joined by a really esteemed guest today, a terrific scientist and a world-famous science communicator, formerly of Yale, Case Western and Arizona State, the author of books such as The Physics of Star Trek, A Universe from Nothing, and The Greatest Story Ever Told, and the recent fantastic book I can't recommend enough, The War on Science. Dr. Lawrence Krauss, thank you so much for being with me today.
Well, it's good to be with you, at least virtually. And now, since you mentioned, I realize I have a copy, even though I'm in the middle of moving. I have one copy unpacked of The War of Science, so at least I can show that. Anyway, thank you very much. It's a pleasure to be with you.
Well, I had a great pleasure of writing a review of The War on Science for The Free Thinker, and I can't recommend it enough. We'll put a link in the description. You are a theoretical physicist, a cosmologist, and a science communicator. Let's start with your science and obviously the passion for it that comes through. Tell us a bit about how you became those things. Were you just a dreamy kid who loved playing with Lego and enjoyed science?
Well, it's one never knows all of the processes that lead to where one is, which is one of the reasons I find origins in general exciting. But I part of it undoubtedly stems from my mother, who wanted me to be a doctor and my brother to be a lawyer when we were younger. Nice Jewish mother who wanted that. For my parents hadn't gone to college, and they wanted their kids to be professionals. So I don't know if that's what got me interested in science. It's hard to know, but I certainly got interested in science, along with wanting to be a doctor. My mother made the mistake, of course, of telling me doctors were scientists, and later on, it was a shock to me when I discovered they weren't all scientists, and I decided I didn't want to be a doctor. That was a very difficult moment in my life. My brother did become a lawyer, which made things even worse. But then what got me fascinated in science was books by scientists. And that's one of the reasons why I return the favor and write books now. But books by everyone from Einstein to 𝐂onnect to Richard Feynman and others. And so that excitement. I read a book about Galileo when I was 10 or 11 that had a big impact on me. It made me think of scientists as heroes.
Mm-hmm.
I'm not sure they're all heroes now, but at least the bravery to speak the truth, even, at personal risk. And then I think it was, I was good. Obviously, I was good at it. But I think what really sort of convinced me to consider a career in science was probably a book by Richard Feynman. I was in some special science program for good students around the city and then around the country. They have special programs for 20 or 30 kids. But the teacher saw I was kind of bored, I think, and gave me the book by Richard Feynman, The Character of Physical Law, and which is a great book. And I didn't understand it all. But it was probably the first time I realized that it hadn't all been done. There wasn't all done by Einstein and all the others, that in fact, there was a lot left to be understood. And I think the realization that it hadn't all been done sort of by dead white scientists made it more exciting for me. But I will say, and this is a long answer to your question, that even then I was torn because there were a lot of things I liked to do. I liked history. I liked acting, actually. And I didn't, and that sort of the non-human aspect of physics, the fact that it was decoupled from humanity, was an attraction, but also a repulsion. And I was very political, and I'm still kind of political. So I bounced around a lot before I did a degree. I did work in history, and before I finally decided to focus on physics. And then I knew I liked to write, but the later career sort of happened accidentally. My advice to me, there are a lot of students who come up to me and say, "Oh, I want to be a science communicator. How can I be a science communicator?" I don't really have advice. I hate to give advice anyway, but one thing I say is, if you're any good as a scientist, you should do science. And then if you're interested in communication, the more science you do, the more opportunities you'll have to reach out to people. And that's sort of in the case of what happened to me. Those opportunities arose, and I took advantage of them in one way or another, and without a plan really. But anyway, it worked out.
Well, the path you just described, you could have been describing Feynman's path. I mean, they're not too dissimilar. Richard Feynman is absolutely 100% my favorite science personality in history. There really is no one like him. Did you ever get a chance to meet him?
Oh, yes. Yeah.
Wow.
In fact, yeah. I don't have it unpacked. My picture in some magazine took a picture of the two of us together once talking
Wow.
physics. But I guess you're not aware. So one of my well, I don't know. I don't know whether I should say one of my favorite books, but one that holds a special place in my heart is, I wrote a book, scientific biography of Richard Feynman.
Yes. Yes.
Like the only one I got asked to do, and I talked there about meeting him and some bittersweet experience of not telling him something I meant to tell him, and people still write to me about that and tell me things because I missed out the experience of telling Richard something. And anyway, yeah, I met him when I was a student. And then later on, the last time I met him was when I was lecturing at Caltech when he was in the audience. But he was a remarkable human being and a remarkable scientist. And the reason I wrote the biography, well, I got asked to. The reason I agreed to do it was, he wrote all these books, Surely You're Joking, Mr. Feynman, and all those other things. The public tends to think of him as a joker and a fascinating, sort of charismatic individual, which he was. But if he hadn't been a great scientist, I think that none of that would have made that much difference. And so I tried to weave his science, trying to explain why he was such a remarkable scientist, as well as a human being. And I'm very proud of that book. And that book, two things. Can I tell you two things about that book?
Of course.
Is it okay?
Please do. Yes.
One, one of the reasons I agreed to write the book was I knew it would force me to read every one of his papers. You don't read every paper. As you're a scientist, if you're a physicist, you don't read all the original papers when you do things because you just don't have time. You learn things in text sometimes, and that's a logical regurgitation of something that isn't often developed logically. But in any case, I knew it would force me to read all his papers. I wouldn't have the discipline otherwise, and I thought that'll be a treat. And of course, I talked to people I knew who knew Feynman as well, Murray Gell-Mann, but also Freeman Dyson. I spent I knew Freeman, and I'd spent a term at the Institute of Advanced Study in Princeton. We used to have lunch every day, and he was a real contrarian. Freeman Dyson was an amazing contrarian, an amazing scientist and intellect. And he was probably the person who, in some sense, made Feynman famous in a way among the physics community, because the work that Feynman ultimately won the Nobel Prize for, Dyson translated it into a way that everyone could understand. And anyway, he revered Feynman. He was sort of like, he wasn't Feynman's student, but he certainly revered Feynman in that sense. Anyway, I remember talking to Freeman about the book, and sending him the book. Now, everything I'd sent Freeman before that, I used to write for the New York Times all the time when we were together, and I'd bring it to him that day at lunch, and he'd read it and say, "This is awful. You're totally wrong about this or that." No matter what it was, I was wrong, because he was a contrarian. So I sent him the book, and I was really concerned about I wasn't. I expected the worst, and I got an email back from him saying, "This is the first book that captured the Richard Feynman that I know." And I thought, I don't care what happens with the rest of this book. That's all that matters to me. And then to cap it off, my friend, the writer Cormac McCarthy, I don't know if you know who he is. He's a very famous writer. No Country for Old Men, and he won the Pulitzer Prize and National Book Award. Anyway, Cormac likes science, and he asked to get a copy of the Feynman book. And then he wrote me back and said, "This book is almost perfect. I can make it perfect if you let me copy edit the paperback." And I said, "Of course." And he said, He said there are two things. He said, one, you got to agree to two things. One, I'm taking out all semicolons and exclamation marks. There's no place in English literature for semicolons and exclamation marks. I said, Cormac, you can do whatever you want. And so the paperback has I just was unpacking some. I saw it has his name as copy edited by Cormac McCarthy, which is a great honor. Cormac just died, but he's one of the great writers of the last 50 years. And the New York Times picked it up, wrote a little story about quantum copy editor. His book is called Quantum Man. Anyway, so those are more than you wanted to know about my interaction with Richard Feynman, or at least the book. But Quantum Man is an homage to someone who had a huge impact on my life.
Excellent. Well, I would be delighted to talk about Richard Feynman all day. I find him just a fascinating figure. And of course, right to the end with the Space Shuttle Challenger investigation, he was doing good public defense of science and science communication right up until the very end on a global scale with that.
Yeah, I mean, I learned a lot about the ethos of science by listening to Feynman, and many of the things I say, I'm sure, are at least channeling Feynman, if not overt plagiarization, when I talk about science and understanding and skepticism and willingness to fool oneself. I certainly learned that from Feynman.
Physics, obviously, very, very broad, and many of your physics heroes are across the whole spectrum of physics. How did you land in cosmology in particular?
Well, again, like almost everything in my life, it was a series of accidents. No planning. I knew I wanted to do well. I actually initially wanted to do what you might call mathematical physics. I did a degree in mathematics and one in physics. And because of another great scientist who just died, so maybe it's worth mentioning him this week, C.N. Yang, who had won the Nobel Prize as a 27-year-old, I think, or 28-year-old, for realizing that nature distinguishes between left and right. But he didn't stop it then. He did so many other seminal developments. He just died at 103 last week. But when I was I think I was a graduate student at the time, but I went back to Toronto to see friends and attended some lectures, undergraduate lectures by Yang, who was visiting Toronto, on something called fiber bundles. But anyway, it's a way of understanding. He did seminal work for understanding the type of theory that describes all the known forces in nature. Now, it's called a Yang-Mills theory, after a paper he wrote with a guy named Mills, Yang and Mills. So, but that turns out to have an interesting mathematical structure that he realized, and he talked about it. And I remember learning about it, and I guess I was still an undergraduate because that influenced my decision. I became fascinated with these things. When I applied to graduate school, I wrote about my interest in this mathematics of what are called gauge theories. I think it's the reason I got accepted to the place I got accepted to, which is MIT. Anyway, I like to do fundamental, the sexiest, most fundamental physics, following Feynman, of course, in a way. And that was the physics of elementary particles. And so I studied that and physics of elementary particles. And that was around the late 70s, early 80s. And that was just at the time when it was beginning to be realized that the universe could be a testing ground for our ideas in fundamental physics. And moreover, many people didn't realize at the time, but perhaps the best testing ground, that accelerators, which have been the best way to discover new laws of nature and particles, were around then sort of reaching their zenith in terms of what they could detect. And in fact, the universe, the Big Bang I like to think of the Big Bang as a particle physics experiment that was done at least once. And now it's just data analysis. Anyway, around 1980, I got interested in some fundamental problems, in part because of one of my professors also, Steven Weinberg, who is probably one of the greatest theoretical physicists of the last part of the 20th century. And so I took even though I did my PhD at MIT, I took almost all my courses at Harvard from Steve. And he had written a book called The First 3 Minutes,
Yes.
which is about our understanding of the first 3 minutes of the universe, which was quite influential. That's when, so the early rumblings of the realization that the early universe was a testing ground of our ideas. And anyway, so I was doing mathematical physics, but I became disenchanted with it, with its lack of connection to the real world. And I had an idea, and of related to the physics of the early universe, and I pursued that for my PhD with a young. I switched graduate advisors from a very senior person to a very junior person, which is usually career suicide. but you do it. But I you do what you do, and anyway, and I was and I finished that, and then I was lucky enough to get a job at Harvard, and with actually same department as Steve, and I pursued, for the most part, what was then an emerging field called particle astrophysics, I was one of the earliest people to realize that one could apply these ideas to understanding the early universe. And that was also potential career suicide, I would say. I've tried to shoot my career in the foot, if not the head, many times. But because I remember, I think you've got me going, because I think I'm sort of contracted to write a memoir, and some of these things will probably come up in that. But when I left Harvard, I was offered a job at the Institute for Advanced Study in Princeton, which is a very prestigious place. I didn't take the job, but one of the amusing things was that they had a physics group and an astronomy group. And see, the problem of doing particle astrophysics is that the particle physicists tend to sometimes view me at that time as an astronomer or an astrophysicist, so they didn't want me. And the astrophysicists viewed me as a particle physicist, so they wouldn't want me. And that was my concern. But in this case, it was even more strange, because both the particle group at the Institute for Advanced Study and the astronomy group at the Institute offered me jobs. and so and they had they thought it was like the wisdom of Solomon. I'm not sure it was wisdom at all. One of the reasons, there were a number of reasons I didn't take the job, but they said, well, we don't want you to, they were in separate buildings. So they said, we've got this great solution. We're not going to put you in the building with the astronomers or the building with the physicists. We're going to put you in a building in the middle. You'll be all alone, but you'll be halfway between them. And that was such a particularly ridiculous solution. But anyway, so, and the interesting thing is that I'm giving you such long answers to your short questions.
It's brilliant. Go ahead.
But I then became later on a professor of, instead of taking that job, I took a job at Yale. And I was from that time onward, I've been a professor of astronomy as well as a professor of physics. But the thing that I point out, which is useful to students, is I never took an astronomy course in my life. I never took a single course in astronomy, and I was a professor of astronomy for many years. Because what people don't realize is that your PhD is not the end of learning, but often the beginning.
Yes.
I certainly learned a lot more about both particle physics and astronomy after my PhD than before. And in any case, I've jumped around. Cosmology is interesting because it's a wonderful way of testing fundamental physics, but some astrophysical processes are fascinating, and I like to do different things. That's another property of my. There are many. It takes all types to do science. People don't realize that. And some people work on a single topic their entire lifetime and do great work, illuminating wonderful aspects of the laws of nature. That's not me. I like to, maybe because I'm lazy or I don't know what, but I like to do lots of different things. And I love to go in and explore something and do something and then learn something new. And so I've done astrophysics. I learned some geophysics and some matter physics. It's almost always in relation to trying to understand the fundamental laws of nature, though. That's the kind of driving guide behind me. And I've done some very mathematical particle physics too, at times. But I think I've driven to cosmology because it's because it's mysterious, and also because it probably is the place, especially now with the extreme difficulty of building new accelerators. It is the place where we may hope to make the most discoveries about the fundamental laws of nature.
Yes,
So there's my
absolutely.
long answer to your question.
Well, that's brilliant. I want to give space and I want people to feel like they're dropping in on a story or a conversation. But it's interesting. We spoke to Lord Martin Rees on this channel recently about that same era, and it was an absolutely amazing era. Must have been fascinating to work in the 80s, the 90s, and the early thousands. And you more than anyone I think I've spoken to, you've sort of been connected with all these institutions: Caltech, Yale, Princeton, Harvard. A very rich experience. It must have been a tremendously exciting time. Obviously, the Hubble Space Telescope in 1993 gets up and running. You had a lot of new data to answer some of these questions, didn't you?
Yeah, yeah. I mean, it's interesting you say it's an exciting time. If you're an astronomer, which I remind you, I didn't grow up to be one. It was. And Martin, of course, is a good friend, and I've learned a lot from Martin. And we have never written a paper together. We've written papers on similar subjects. We've talked together many times, and 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 I've written blurbs for his books and vice versa. But the interesting thing is, it's bittersweet, because the golden era of fundamental particle physics peaked just before I began my PhD. I wrote about it in one of my books, The Greatest Story Ever Told So Far, you mentioned. The 1970s, the late 60s and early 70s was an amazing era. We went from understanding one force in nature, the force that Feynman was involved in helping to understand, won the Nobel Prize for, to understanding three of the four forces in nature and having a mathematical framework that seemed to suggest we'd understand the fourth force of nature, all within a decade. I mean, it was just the most revolutionary period of sort of fundamental understanding of nature in a long time. People don't think of it that way. They think of the early 20th century with quantum mechanics, which of course was profound, and relativity. But in terms of understanding fundamental forces, our pictures changed completely between 1965 and 1975. And I started my PhD in 1997. Some of the fundamental experiments that demonstrated the correctness of that theory were done in the late 70s and early 80s. But that was it. I mean, the standard model of particle physics was developed by then and accepted, and the Nobel Prize went to my now friends, then mentors, Steve Weinberg and Shelley Glashow, and I didn't know Abdus Salam, who they shared it with, but and that was it. I mean, and then later on, other friends of mine who won the Nobel Prize, Frank Wilczek, a close collaborator, David Gross, that they developed the standard model in the 70s, and what's been frustrating is in the intervening 50 years, except for the discovery that neutrinos have mass, there have been no developments that have led us. The standard model has been frustratingly correct. And we know it has so many open questions and weird features that it can't be complete. We know it can't be the complete story. But there have been no experimental hints and no theoretical breakthroughs that have demonstrated how to go beyond the standard model. So particle physics has been, at that zenith. I'm not saying it's going down, because there's still all these puzzles. At the same time as sort of cosmology was ramping up because of the not just the Hubble Space Telescope, but the Cosmic Microwave Background Explorer satellite, and which changed everything, understanding the cosmic microwave background, and all of these new technologies were developing, and science is an empirical discipline. So while accelerators had pushed particle physics forward, new telescopes that could probe not just visible light, but microwave radiation and gamma wave radiation and X-rays and now gravitational waves. All of those new technologies were coming online and turning astronomy and cosmology into a science from an art. And so the golden age of cosmology was beginning at the same time. And I was at that intersection. And it became very exciting. And in fact, unbelievably exciting. And by unbelievable, I mean no one would have believed, literally, that within a decade or two of the 1980s, that we would have an empirical handle on the universe going back to its earliest moments, almost. When I was a young faculty member at Yale, and that would have been in the 1980s, mid to late 80s, there was a colleague of mine, well, Gus Ulmer, I guess I can say it. He was a distinguished astronomer. He was for a while chairman of the astronomy department. And I remember, I was working on dark matter at the time, and there were every week, not only were the ideas of dark matter changed, but it would die. People claim there's no evidence for dark matter anymore, and then it would be reborn. I always say dark matter is real because it's died and been reborn many times, like many saviors. Anyway, Gus said to me, he felt that there was, we were trying to understand just the expansion rate of the universe, which is with the Hubble constant, which is one of the most fundamental numbers in the universe, was only known to within a factor of 2 in the 1980s. There were two groups. There was one that said this number was 100. It doesn't matter what the units are. And another group that said it was 42, a very interesting number if you like literature, like Douglas Adams.
Of course.
And so the weird thing is they measured this Hubble constant, and one group said it was 100 plus or minus 5, and the other group said it was 42 plus or minus 5, and obviously it can't both be right. So, and the funny, I remember at the time saying, well, the obvious answer is going to be 75, halfway in between plus or minus 5, and then the actual number is 70. It was halfway in between. It's not too surprising, but it's made me very suspicious of claimed uncertainties in astrophysics, because it's hard to do since then. But Gus told me, he said he thought it was a fundamental theorem that you'd never be able to measure the fundamental parameters of cosmology, that astrophysics uncertainties would always come in and cloud the picture. And he said that to me probably in the late 80s. And within a decade or so later, we knew the Hubble constant to within 1% accuracy, 1 to 2% accuracy. We measured the fundamental fluctuations that led to galaxies, the primordial spectrum of fluctuations that was created at the beginning of time. We now measure gravitational waves. I mean, we know the fundamental parameters of cosmology now, in some cases, to 5 decimal places. But in the 1980s, we didn't know them with a factor of 2. So Gus and Gus had good reason for saying what he did, because in the 60s and 70s and 80s, people had claimed to know this number, like the flatness of the universe, the curvature of the universe, had claimed to know the number, and then it turned out their claims were wrong. And now we know the universe is flat to 1%. But again, people thought it was open or closed. So things have changed dramatically. And indeed, it has been an exciting time. And it's been exciting for me to have been a part of it. I was going to say a witness, but I've actually obviously played a role too. And I'm proud of the role I played in. In particular, the discovery, the strangest discovery of all, that empty space has energy.
Yes.
Which and the dominant energy of the universe resides in empty space, which I am pleased to have been one of the first people to argue was, in a convincing way, was there, and then it was discovered to be exactly what we said it was 3 years later.
Yes, and you've outlined some of this in your popular writing.
What was that?
You've written about some of this in your popular writing. I want to ask you, because you
absolutely.
Because you've touched on it a little. You started the Origins project in 2008. Could you outline a bit of what that was about, how it got started, and what it entailed?
Yeah, again, it's a long and winding road, so be prepared. Well, here's the deal. I had left Yale, partly because I hated New Haven. Sorry for the people living in New Haven. When my daughter was going to school, I didn't want her going to school there. Anyway, I had left Yale and moved to become chairman of the physics department at Case Western Reserve University, which was a very attractive offer because I was given 12 new faculty positions to hire and build a new department, which was unheard of at the time. And it was wonderful. And it was very exciting. I built a really dramatic new department, and it shot up in the rankings. And anyway, it was an exciting time, a very busy time, because I also wrote my first, the physics of Star Trek during that period, and everything, lots of things changed. But I created a center for research and education in cosmology and astrophysics. I'm trying to remember because we did an acronym CIRCA. And that was fun. And I brought people together, and we had some interesting meetings. The first meetings on a number of topics that later changed the field, actually. But as my experience increased, and I guess my celebrity or notoriety increased, I got exposed to more and more different kinds of science, which always interested me. And around then I wrote a book called Atom, which was a story of an atom from the beginning of the universe to the end. But to do that, I had to learn geophysics and biochemistry and biology and planetary science, which was fun, of course. And I began to see my interest began to broaden. And when I thought about talking to the public, the connections between so many fields was there. And at the time in that region, there was an incredible museum of natural history where, in fact, the person who discovered Lucy, that famous skeleton, Don Johansen, had been the director of that museum, of Cleveland Museum of Natural History. And it was a wonderful collection of things, and there was a wonderful art museum. And I got connected, and then there was the Cleveland Orchestra played in Severance Hall, and I happened to ultimately solo with them, but that's a different story. And so all of those cultural, intellectual connections were swimming around in my brain. And I thought, it would be great to, the forefront fields, the new discoveries aren't going to be made just in one field. I'd already jumped fields, right, from physics to astronomy, but, these 18th century disciplines weren't necessarily the best way to make new discoveries. And to bring different people together from different fields to illuminate things with different thinking might be a good way to do that. So I had this nascent idea to create something, and I was calling it the Origins. I didn't know what to call it, Origins. And I met with people at the different institutions and talked to my university. But Case at that time was undergoing a upheaval, a part of which I was involved in. I got rid of a very nasty president who was hurting the institution and was losing money. And around that time, I happened to be asked to give a lecture at Arizona State by a colleague, a well-known colleague, actually. And he said, I think you might want to be our president. So I met the president at Arizona State for breakfast. And I was impressed at the time, the fact that he met me alone. Usually presidents have handlers. Because presidents, nowadays they need handlers, most of them. Because they're just glorified fundraisers. But he met me alone, and he was interesting. He asked a lot of questions. I told him of my ideas about what I was doing in Cleveland, and he said, "Well, this resonates." He decided to make new schools instead of departments. There was a school of Earth and space exploration, there's a school of this and that, life sciences, bringing different departments together, because he was the one who said 18th century disciplines should not be the way to learn things. And so we resonated fine. And then a month or two later, I got a call from him saying, "Okay, what do you want to come here and do this here?" And basically, it was basically, yeah, what do you want? Whatever you want. And it was an offer I couldn't refuse, in a way. And he made pretty certain I couldn't refuse. It's difficult. And it was challenging because I agreed to move there. But at the same time, it was a vision he and I had, and one or two others at the university. But it was the first time I went from a private institution to a public institution. And I was scared about that because I'd always been at private universities, and I was worried about the bureaucracy and other things. I went from a small university, all the universities are small, maybe 3,000 or less than 3,000 undergraduates, maybe, to an institution that ultimately had 90,000 undergraduates, or 90,000 students, not 90,000 undergraduates.
Wow.
And wow is right. And of course, a very different environment in Arizona versus Cleveland.
Yes.
Anyway, we built the Origins project, and I met with a lot of naysayers initially, but I put together a group of 10 or 12 people from different areas, and I decided to start things with a bang. It was ambitious. Said we'll begin things with the biggest meeting that's ever happened with 100 best scientists and scholars in all these different fields. And we managed. I had a good Rolodex. I don't think anyone believed it would be possible. It was. It was an amazing event in 2010. And then we decided to, have workshops on different areas where we'd bring people in from different areas, like origins of human uniqueness, where there wasn't a lot of understanding, and bring people in and see if we could create a new discipline or get. It was sometimes as an abject failure, but with every one of the things we wanted to do was run a public event, so that we could not just bring the science together, but expose the public to the leaders. And sometimes those people were famous, and sometimes we had associated events with people who were famous. So we had a workshop with neuroscientists and AI people on creativity and madness, and the public event was with me and Johnny Depp. So so anyway, it was a lovely time, and we'd have 3,000 people come to our events, and it was great, and it was flourishing, and it was a wonderful experience.
And
at the same time, what?
I was going to say, this was the same year that you were involved with President Obama's Science Policy Committee, wasn't it? So,
let's see. I think it was earlier. Obama got elected in 2008, and I moved to Arizona at the end of 2008, beginning of 2009.
Right. Okay.
And so I've been involved. Remember, I didn't get involved in the administration once he became president. I only got involved in helping him get elected as president. I didn't want to be a member. Well, I'm not sure I would have been asked, but I certainly, it's not something I ever wanted to do, was become part of an administration.
No.
But anyway, so I had just done that, and I'd already been fighting the public at that time. I was going to say celebrity. I guess celebrity is the word. My public profile had already become pretty high.
Yes.
And I was involved in a lot of things, including public debates about science and politics, and I used to write regularly for the Times and other things.
Yes.
It was around then that I used to visit the Institute. Because I visited the Institute when I was in Cleveland. So anyway, so it was a great time, but at the same time, I always, my sights were always bigger. So I went from a small university to a big university, and I became more and more interested in the things beyond academia and the public and institutions. And I had already become a little disenchanted with universities, and not disenchanted, but I just had learned to admire entrepreneurs a lot more. People who didn't have I didn't realize how utterly safe a university environment is. There's no safer environment in nature. It's a privilege. You're given everything you want. You have this whole institutional infrastructure behind you. You can think. You used to be able to say what you wanted, and do what you wanted, and I admired those people who didn't have that safety net.
Right.
And so I'd already thought of. I looked into creating a nonprofit foundation. I thought maybe we should go beyond the university, and I did. And also, I should say, well, actually, before that time, I'd already made the decision not to go up in the ranks of the universities. Before I went to Arizona, I'd already been, people had been making offers to be dean or president of a university and things like that. I dodged those bullets happily. I'm really happy I dodged those bullets. But I thought, it would be fun to move outside. I tried I talked to the president of the university about taking a half-time position. He said, absolutely no way. But anyway, but when I decided to leave the university, because the university had become I'd done what I could do there, first of all, I think, and also there was nothing much. The environment, as university began to change, the environment became less pleasant. Um, yeah, a number of members of the public agreed to support me in creating a foundation, and I thought, well, I'll carry on the Origins project, but as a foundation, and try and broaden it, and created this foundation that does three, it sort of has three legs. One is the podcast. We turned the public events I did in Phoenix, and I thought I want to reach a broader audience. And I'd done events with sometimes with just one person, sometimes with a bunch. I still do them, public events, but not as much. And I thought if I could try and get people from every, even broader areas than we'd done before. And in the first few months, the young gentleman who were producing it, we recorded 19 podcasts in 4 different countries in 20 days, I think. And I make a point of reading almost every book by everyone. It was a killer, let me tell you, but it was great. We went to have Richard Gervais in London and Stephen Fry there, and my friend Shelley Basha won the Nobel Prize in Boston, and we're in New York. We did Woody Allen later, I think, but anyway, and so that was fun and exhausting. But I also wanted to have public events, and then we also wanted to do another thing. In all of these, people get a chance to experience the sort of leading intellects and who are changing our ideas of the 21st century. And I like to expose the public to them, but they get a limited exposure. So I thought if we develop, and I'd started this at ASU, travel experiences where people could spend a week or two with these people and really get to know them would be great. And so we started creating travel experiences. We went to the Amazon and we'd done Antarctica, the Amazon, and then Greenland and the Mekong Delta and most recently Bhutan, and they're wonderful experiences. So we had originally also thought of running scientific meetings as well, like I used to do at ASU, but that became harder, especially during the pandemic. Maybe we may do that again, but yeah. So anyway, it's been a fun experience to work with the members of the public and work in these different areas. So, and at the same time, because of the beauty of what we're doing right now, I can do not just that, but also my science, to the extent I'm able to do that anymore. Also, I'm collaborating with several people I've never met on some physics papers. And anyway, another long answer.
That's okay. With everything you said, many people have reaped the benefits, and society in terms of science communication has reaped the benefits. I'm aware we've already been through so much time. I haven't even mentioned the war on science and the public understanding. But let's see if I can tie this together. So two things to tie together. I spoke to Professor Kenneth Miller recently, who 20 years ago was part of the trial in Dover, Pennsylvania about intelligent design.
Yeah, we worked together, Ken Miller and I.
Yes,
on fighting. We've done. Yeah, I haven't spoken to him in years and years. Yeah.
Yes, I noticed that you also help provide opposition to intelligent design. The other thing to tie in here is I was very lucky to lead a team of students once, and we won a competition to have an experiment flown to the International Space Station to be performed.
Oh, that's great.
Oh, it was incredible. It was SpaceX CRS-29, so that was 2 years ago, and it got performed and written up by NASA last year. It was amazing. I remember posting about this online. It was a night launch. Night launches are the best. And the amount of flat Earth and anti-space moon landing hoax, like everyone came out of the woodwork to attack my post. And that was one of my first experiences with those guys. And those guys hate me with a passion now, and I guess the feeling is mutual. But you, as much as anybody, are at the forefront of the fight. It's staggering to me, the skepticism gone too far, skepticism into madness of science, authority, truth, reality.
My favorite quote is from the former publisher of the New York Times, who said, "I like to keep an open mind, but not so open that my brains fall out."
Yes,
That's always been my guide.
yes, and there are brains all over the sidewalks now, from teenagers and children, and it could make one despair about the future of humanity. But you have seen this and dealt with it not only in the public square and in things like trials with intelligent design, but now in the very institutions that have been some of our finest, have been the bulwarks of what's been so great about the West in terms of education and knowledge and driving humanity forward. So, talk about the war on science and uh, share your thoughts on what can be done to win uh, for those of us involved with academia and the sciences.
Well, I mean, it's long. As I said, there are many wars on science, but I mean, I've been involved in them. I mean, I think my public notoriety actually began because of my fight against intelligent design.
Yes.
Which because the biologists weren't doing a good job, and I did, and I helped provide some of the information when Ken was in the trial in Dover. But I used to fight, and it was unfortunately the fight on against science came from the right. It was, I remember having a big debate at the American Physics Society meeting with the quote unquote science advisor to Bush.
Mm.
It was an easy debate to win because they were just such nonsense. But what began to be those were external attacks on science in many ways, from flat earthers to religious right to political right. And what did change over the last decade, and it's mostly over the last decade, although there's some people like Jonathan Rauch who were prescient and realized there were changes happening even earlier, was that the well-meaning left began to slide into the crevice or chasm that is postmodernism.
Mm.
It began to slide into the notion that because there were inequities in society, that there were in the same society that had also led to the development of all of the great ideas of science and the Enlightenment, that there must be something fundamentally flawed about science and the Enlightenment. And that included the idea that there's objective knowledge, and the notion that all knowledge is subjective, or at least contingent, and that everything has to be understood in terms of conflict and oppression and power began to take over. Well, I mean, there's nothing new about that. That had taken over in the humanities in the 1980s.
Yes.
And when I was at Yale, as I began the book, because you've read it, we used to make fun of it in the sciences. We used to make fun of it. We were up on Science Hill. We'd make fun of the English professors and their departments with deconstructionism and the notion that there was no objective meaning to language.
Yes.
It was all
Derrida. Derrida was at Yale at that time, wasn't he? Was he there at that time?
Maybe. I don't think so. Maybe he was. Derrida, well, obviously one of the most important people, but if he was at Yale, I didn't know it. It's a good question. I'll have to look it up later. He may as well have been, because that's what it was his nonsense that was being spouted. And we said it would never happen here. And then what you began to see was it began to slowly encroach. And it encroached again because of good intentions, I think. I mean, some historian will write this later. Some people have already written histories, but maybe they'll need a little more perspective than current times. It was recognized even when I was chair of a physics department in the late 80s and early 90s that there were disparities. There were demographic disparities in the hard sciences, namely too few women in physics, say. And so, like every good, kind of liberal people, the idea was, let's try and make sure we can try and expand that. So even in the early 90s, when I was chairman of the department, we would obviously be searching to try and, I was happy in my department. I hired the first 2 women faculty members. I'm proud of myself. But when we did a search, and this is now 30 years ago. Remember that, 30 years ago, not 5 years ago, but 30 years ago. whenever we made a search for someone and hired someone, if we didn't hire a woman, we had to write a special set of forms and to explain and justify the hiring that we made. Okay. That was back then. Okay. I mean, and so there was a big effort, an affirmative action effort to broaden things. It's not new. It's been going on for a long time. But yet, what you began to see was that people, that effort caused a small group of people, in particular, a group of bureaucrats at universities who then became in charge of kind of trying to become the demographic police to ensure that you weren't excluding on gender, which, I mean, instead people were going upside, standing their heads to do quite the opposite. But that kind of mentality began to grow. Yeah. And something happened. And then, of course, it took on a new course with George Floyd in the United States with race, to this notion that not only were there demographic diversities that needs to be addressed, but that those demographic diversities reflected underlying systemic inequities, racism and sexism. And that those had to be addressed by institutionally, and without any evidence that there were systemic racism or sexism. And believe me, there isn't in academia. It's quite the opposite.
Yes.
Academia had been one of the most enlightened places in the country. Now, there are systemic inequities in the United States and in other countries, and they need to be addressed. But they shouldn't be addressed at the level of full professors. Okay, you know, I taught in Cleveland, which had inner city schools where the kids didn't have books. You know, and that's where you want to try and address things, to try and raise things. But anyway, that mentality took off, and it in an amazing amount of time overwhelmed the academy, to the point where there was such sensitivity to possible inequities that the policing of what you say began to be important, and people began to be afraid of what they say, and also that political ideology began to impose itself on science. So it began to be that not only were people so concerned about these demographic disparities, but they became convinced that there were these systemic, that racism and sexism was systemic, and therefore that had to be fought. And bureaucracies, university bureaucracies, were created to try and fight that non-existent problem. And whether you believe it or not, non-existent or not, the point is it hadn't been demonstrated empirically to be a problem. It was assumed. It became religious.
Yes.
And I fought religious dogma my whole life, I guess. Yes. And this is a kind of secular religious dogma. But what's worse, there are two things that came from that. One, that the university started trying to actually impose ideology by doing litmus tests on hiring and getting people to do loyalty oaths, and something that you shouldn't ever have in academia. But worse than that, the language began to be policed, and people who spoke out began to be punished. And when it really hit me was I obviously was writing about these things, and I couldn't write for the New York Times anymore about these things. It was liberal, but I wrote for the Wall Street Journal. I wrote a piece, I think in 2020, called "The Ideological Corruption of Science," which concerned me. And the thing that really drove home how serious the problem was, for me anyway, was I got a lot of letters from academics, email letters, in the next weeks. And what surprised me, well, they were all from home computers, none from university email addresses. They'd all written from home. And a number of them used false names. And they wrote to me saying, I'm writing this under an assumed name because I'm worried my supervisors or my administrators will learn that I agree with you. Well, my God. that sounds like the Soviet Union when I was growing up, or the Stasi, or East Berlin or Hungary. That's up academia. That's not academia is one place where you're supposed to be able to say anything and provoke. As I've always said, the purpose of education is not to make you comfortable; it's to make you uncomfortable.
Yes.
Because only then are you going outside your comfort zone. Are you learning? So that's that problem. And anyway, I began to write more about it, and then realized that. And I thought of writing a book. But then I realized if I write a book, well, it's going to be tainted with, with it, whatever I'm going to be labeled this or that or the other thing. And so I thought, why not try and get a broad group of people from within? Because there are a lot of people who are criticizing academia from without. But I wanted to get people who were within the system. So their criticisms, I think, had more importance. And get a diverse, and by diverse, I mean intellectually diverse group of people. And by that, I mean different disciplines, all the different disciplines, and also people, more importantly, whose politics were both from the left and the right. So we couldn't all be labeled right-wing, although that's happened. Anyway, I managed to, so that's a long story. I managed to herd 39 cats and get a wonderful group of people who I told to write on whatever they wanted to write on, because I didn't want to tell them what to write on, but it came together in a nice way. And we produced this volume, we produced the volume, we finished it in October of 2024, and Donald Trump was elected in November 2024, became president in January, and a whole different kind of attack on science began. And what is amazing to me is the attack from the left, from the woke left, is, well, how dare you talk about this problem when the real problem is, and there is a real problem, and I've written about it, is the Trump administration dismantling science and attacking universities. It's a huge problem, and a extremely an immediate problem that could decimate American science, and is already beginning to. But the fact that problem exists and needs to be fought in the ballot box and legislatures is one thing. But it's different than this problem. This problem, although we alluded to it I added a note in proof in my introduction, that culture war that needs to be fought is embedded in bureaucracies at universities, in a whole group of people who've been hired who are true believers, and that attack on free inquiry and open inquiry and free speech still exists at universities, and until we free that, until open inquiry becomes accepted, and people are not afraid to speak out, and people aren't canceled for saying the wrong thing or have their lectures stopped because they're saying the wrong thing. It happens all the time, especially now with the anti-Semitism in the United States. I think it was my friend Steve Pinker at Harvard who said something like, where at the time of the big anti-Semitic demonstrations after October 7th in U.S. universities, when they said that students, leave their colloquium on the harms of misgendering and go to attend a Kill All the Jews rally. I mean, it's just, the dichotomy becomes very large. So anyway, that's the origin of that book.
I was delighted to see in particular the chapter from Alan Sokal, who famously lifted the lid on some of the ideological invasion of science a while ago. I
was so happy that Alan agreed to do it. I'd never met him, but when when we were putting together, I was in England and met Alan, and I was pleased that we did an event recently to launch the book in the UK, in London a few weeks ago, and Alan was on the panel.
Yeah, that's wonderful, really wonderful. And the fact that this book can come out and be released now is at least a glimmer of a sign of hope that the dialogue is growing, and hopefully people wake up.
Well, that was the point. The idea. Yeah, that was the idea. If academics were afraid to speak out, I thought if I got 39 people who are well known, who are willing to speak out, it might convince them that it was worth speaking out. Yeah. I should say the book has been attacked mercilessly in the U.S., at least. As a right-wing diatribe and fascist and all the things you could expect. And but I'm not surprised.
No, neither am I. And it's being attacked by people who obviously haven't read it as well. But
yeah. Well, that people not reading my books and attacking them, or my writing. But yeah, this is definitely the case. It was amazing when the book came out on Amazon. Within a day, there were like, I don't know, half a dozen 1-star reviews saying how awful it was, when you know that they couldn't have read it, could have come out that day. And it's it's amazing. But anyway. Yeah.
Yes, you've already been so generous with your time, and there's 100 other questions I'd love to ask you about your science, about your public outreach, and all of that. But I know you're a very, very busy man. So, if people want to find out more about you, your work, and your writing, where should they go?
Oh, anywhere.
Yes.
Well, though, you can go to the Origins Project Foundation site to see some of the events we do. Also, we try and maintain a webpage, lawrencemkrauss.com. But, and my books are freely available anywhere in principle, certainly online. It's easy to find my writing. And on Substack, I have a Substack called, I think it's Lawrence.Krauss. Well, the Substack's called Critical Mass, where we also produce a lot of writing and links to our events. So there's lots of places to find me. I seem to be lurking in a lot of places.
Excellent. Thank you so much. It's a real pleasure and honor to speak with you, and keep up the wonderful work.
Well, thanks. And maybe we'll have another chance to talk about all those other things. And I'm sorry my answers were so long, but maybe you'll get to ask more questions later. It's been a pleasure.
I'd be delighted to. Thank you.
Thank you.
Thank you so much for watching. Don't forget to like and subscribe. Stay tuned for more amazing conversations with incredible researchers who are changing the world we live in and driving humanity forward. Feel free to check out my Instagram at polymath_Sam, or go to my website at www.sam-mckee.co.uk.